Okay, so we wanted to estimate the damping ratio of our actual steel support. And the way we said we were going to do that is we're going to attach a mass to it of 120 pounds before we order this big expensive fan. We want to see what the damping ratio is to see if it's going to be sufficient to damp out our vibrations due to the fan. So we attach this mass to it, we measure the response. We started out at a known position, place it a certain amount, and we watch it oscillate. We displace it initially. Here's our displacement. We'll say that's x, and here's time. And it looks something like this. And all we really need to know is where this second peak is. Right? We need to know where we started it and what the second one is. Or, if you can't measure what the initial displacement was, but for some reason, but you can measure a later one, then you can measure what this one is. But all we need to know is the ratio of adjacent peaks. And then you can use our formula for the damping ratio. The damping ratio is equal to the negative logarithm of y1 divided by y2, or y naught. So it's x in this case, so let's go use the symbol x instead. x1 over x naught. And it's just the ratio of the two over 2 pi. So let's say we don't even know what the actual, you don't even have to have or you don't have to know what the units are. You could just see on a plot, without even knowing what the units are, that this here is 75% of whatever this height is. So let's say that this is here, 75% of the whole, where this is the 100%. If you know that, you can do this. Negative logarithm of 0.75 over 2 pi. Our damping ratio in this case is about 0.0458.